Hi everyone, let's continue with few more examples on designing of DFA. Here language is given in terms of A and B and some condition is given in terms of number of A's and B's. So based on this language we can write down minimum length string. First try to find out some string based on the values of m and n. Here m is starting with 0 as m greater than equals to 0. So starting value of m will be 0. Here n greater than 0 means starting value of n will be 1. If I write here a raised to 0 and b raised to 1. A raised to 0 means what? 0 number of a's but 1 b is allowed. So our first minimum length string will be b. Similarly, if I keep this m0 and n as it is 1, so what? a1 b1. Similarly, if I say m is 1 but n is 2 or m is 2 n is 1 or both can be 2, so we can write down the string as it is then ab or a1 b2 based on the value of n2. a1 b2 means what? Single a followed by double b, or we can say a2 b1. This case means 2a's followed by 1b. a2 b2 means 2a's followed by 2b's. We can write down like this, and like this we can design the strings. Now if you observe all these minimum length string set, it shows that language is saying that all a's and then followed by all b's. If a's are coming, then all a's, then followed by all b's. But after b, a are not allowed, because if a's are coming, then b will come. But after b, a's are not allowed. So let's start designing DFA for this. Q0 is our starting state. Then first symbol, first string b should get accepted. It means what? Transition of b should go to the final state. So I am making q1 as a final. Hence b is accepted. Next possible string is ab, or I can say abb. Now based on this we need to make automata deterministic, because all these strings will be covered when we will make the automata deterministic. How to make it? I want to make q0 deterministic because from q0 there is a transition for b, but transition for a is missing. So we need to find transition for a from the state q0. How to find? Our uniform method. How to reach to q0 from starting state? How to reach to final state from the q0? q0 itself starting state, so no need to read anything. q0 to final, we need to read the single b. Check, is this valid string? Yes, AB is a valid string. It's in the MLS as well as it's following our language. All A's, then all B's. Q0 looking for single A or double A is also allowed. This B as it is. Is this valid? Yes. 2AB. All A's then B. It's also valid string. If triple A is coming followed by B, this is also valid. All A's then B. If suppose A's are not coming, means what? Epsilon contains 0 number of A's. This B as it is. Epsilon dot B becomes B. Single B is also valid. As per our language condition, single B is also valid. What does it show? Q0 is a state looking for epsilon means 0 number of A's. Single A or double A or many A's. It means what? Q0 looking for 0 or many A's. Q0 looking for 0 or many A's. Whenever there is a scenario of 0 or many in TOC, we need to give the self loop. At which state? State is Q0. For which symbol? Symbol is A. So there is a transition from state Q0 for symbol A as well as for symbol B. Now Q0 becomes deterministic. Now similarly try to find transitions from the state Q1 to make it deterministic. How to find it? Write down the state which I want to make deterministic. Here I want to make Q1 deterministic. For which symbol? Symbol A. Same method. How to reach to Q1 from starting state? Starting is Q0. How to reach to Q1? By reading B. How to reach to final from Q1? Q1 itself is a final. Is this valid string? No. Why? Our language says all A's then all B's. This is what language is expecting. Here after B, A is coming and this becomes invalid string as per the language condition. So transition from the state Q1 for the symbol A will go to the dead state. Why? Because it's reading the invalid symbol. That symbol is A. After B, A's are not allowed. So transition for this A will go to the dead state. Because automata, if reading invalid string, that automata will go to the dead state, and once it is in dead state, it may read any time of symbol, any number of symbol, A or B. Now we need to find similarly transition for B from the state Q1. Q1 is trying to find transition for B. How to reach to Q1? By reading B. How to reach to final from Q1? Q1 itself is a final. Q1 is looking for single B? No. Q1 is looking for double B also, triple B also, or many B's are possible. Starting to Q1, this path contain B. Now check, are these valid strings? Double B is allowed. As per our condition, A raised to M, B raised to N, if M is greater than equals to 0, if I write here A raised to M, B raised to N, M starting value is what? 0. So A raised to 0. N value should be greater than 0. Means what? N value should be 1. Or I can say N value should be 2. Or I can say N value should be 3. A raised to 0 means what? Epsilon. This B, single B may come, double B may come. It means what? Single B, triple B, all are valid string as per the condition given in the language. As M is greater than equals to 0. It means what? A may come or may not come. So all are valid string. So at Q1 we need to find transition. So here single B transition, double B, triple B, starting to Q1 B as it is. If suppose at Q1 no B's are coming, no B means what? Epsilon. Because starting to Q1 we have already one B. At Q1 epsilon is coming, so B dot epsilon becomes B. This is also valid. So Q1 is looking for this kind of transition. Q1 looking for epsilon means 0 number of B's, 1B, then 2B or many B's. So 0 or many B's. Q1 is looking for 0 or many B's. So we know whenever there is a scenario of 0 or many, we can give the self loop. Where? At state Q1. So there is a self loop at state Q1. For which symbol? Symbol is B. So we have transition for B from state Q1 as well as for symbol A. So Q1 become deterministic. Both the states are deterministic. Hence this is deterministic finite automata for the given language. You can practice similar kind of question where sigma contains 0, 1. In the next session we will see how to design DFA for this language. Thank you for watching.